Hey y'all, this is the first of two videos for today. This is entitled Derivatives Using Data. Water is flowing into a tank over a 24-hour period. The amount of water in the tank is modeled by a differentiable function, W, for 0 is less than or equal to t is less than or equal to 24. Where T is measured in hours and W of T is measured in gallons. Values of W of T at selected values of time T are shown in the table below. So at T hours, there are 150 gallons in the tank that is referred to in this problem. We're going to find the data in the table to find W of 8. Use approximate units explaining the meaning of your answer. Appropriate units, not approximate units. At 8 hours, there are 221 gallons in the tank. It is very important that if you can, you put your answer in context. And it is also important to note that it does not say 8 a.m. You may get the entire thing wrong if you assume the time here. So now we're going to use the data in the table to find the inverse of W at 257. And that would, of course, be 12 hours. And that means that when there are 257 gallons of water in the tank, it must be 12 hours into this process. Now we're going to use the data in the table to find an approximation for W prime of 15. Show your computations that lead to your answer. Using appropriate units. Explain the meaning of your answer. So we're looking at W prime of 15, which is not up there. But we do have values at 12 and 16, and those are pretty close. And we also, I wanted to use something else to be fancy, but I don't think that's a good idea. We're just going to go as close as we can. So what we see here is a slope of approximately 37/4, and we can say that the rate at which the tank is filling with water is approximately 37/4 gallons per hour, which actually turns out to be a pretty decimal. So I'm going to go ahead and refer to it in decimal form. Okay, as you can see, I caught myself. This is an approximate rate. So you need to make sure you insert those words or don't do the righto that I did. Now we're going to use the data in the table to find the average rate of change over the time period from 4 to 20 hours. Okay, so this was just algebra slope to find that average rate of change. And we get 10.813 if we round and 10.812 if we truncate. Rounding is something you are hopefully familiar with. If you are not, you need to let me know if you do not understand how I got 10.813. Truncated means you just lob off whatever's after the third decimal in this case. On your AP exam in college, rounding to the 10th, 100th, 1000th, rounding to the 1000th is considered enough of an approximation. So you're always going to the third decimal place in your answer, and you absolutely must use those approximate symbols. Okay. For 0 to 24, there must be a time t when the tank contains 200. Whoa, I read that wrong. For 0 is less than t is less than 24, must there be a time when the tank contains 265 gallons of water? And justify your answer. Okay, so f is continuous on 0 to 24, so it satisfies one of the conditions of IVT. The two endpoints have different y values, so it satisfies another condition of IVT. And the y value that we are looking for is its value is between the two endpoints. Therefore, we can now state that by IVT, there must be a time t when the tank contains 265 gallons of water. All of that is about as succinct as you can get with your answer. So you need all of that information there. Okay, oops, last page. A model for the amount of water in the tank is given by A of t equals 1 over 225 times the quantity negative t cubed plus 30t squared plus 1800t plus 33,750, where A of t is measured in gallons and t is measured in hours. Use your calculator to find A prime of 15. Okay, I want to be super clear here. If you have a TI-83 or a TI-84, you're set. If you do not have one, you either need Wabbit EMU or GraphingCalc 83. The GraphingCalc 83 is something like $6.99, and it is available on an iPhone. They also have made online TI-83 or TI-84s free during the pandemic. So what you're going to do, oh crap, my phone just fell asleep. Okay, you go to Math, you push the button that says Math. Then you push, I think it's number 8, but I'm going to write down the actual word also. So once you've put in the word NDeriv, different calculators look different. But basically you need to first put in your function, then you're going to put in the name of your variable, and then you're going to put in the value at which you want to find the derivative. And I'm going to try really hard to write all of this, there are 2 different ways that I've seen this displayed, so I'm really sorry that I can't do more. If you really don't have a graphing calculator, there are plenty of online ones, so don't stress out. I'll get you a TI-84. We'll figure out how to do it. So these are the 2 primary ways I've seen it in the calculator. Oh crap, that's weird. In the calculators. I'm so sorry. Sometimes the pen just what is it doing, y'all? It just, what? Okay, just forget it. I won't do that. Okay, so the top one is, well, I'm going to say super old, but maybe calculators that haven't had an update in about 5 years. And the bottom one, which I forgot to set a parentheses, forgot to close them. The bottom one is the one everybody feels really smart when theirs looks all pretty like that, but there's really not that big of a difference. So either way, you're going to find the derivative at 15 using your calculator. And this is a very necessary skill. I skipped it 1 year when I was teaching calculus. Oh, what was I thinking? Stinking Lincoln. So, yeah, it's important. It makes you go faster in certain sections, especially the calculator free response section. And, you know, when you're given a calculator, whether it's in college or on the AP exam, you'll want to use it. Also, would you please remind me next time to go over a few calculator tricks, like how to put a fraction in the calculator in a way that isn't division, or it is, but doesn't use the division button. Okay, so what you should have found, calculator is misspelled. I never noticed that before. What you should have found is that you have the derivative at 15, or the slope at 15, is approximately 8.999 repeating. So really your answer should be 9.000, and it still should be approximate. Very clearly approximate. We did not ask for an explanation or justification. So we need our units, and then we move along. If you look at the next part, it asks you to use the model given in part F to find the average rate of change of A of t over the time period 4 to 20 hours. So we need to use A of 40 minus A of 20 minus A of 4. It's per hour, isn't it? And put that over 20 minus 4. So this is algebra slope again. Now, I went ahead and put my entire function up here into my graphing calculator in Y1 to find good approximations. I didn't want to put that whole entire function in twice with two different values in for t. So A of 20 is 327.778. I do prefer to round. Minus 183.849. Also, we have a little issue. This is no longer equals. This has become approximately. And we put that all over 20 minus 4. And we get 8.996 gallons per hour. So our approximation for our derivative is very close to our approximation for the average rate of change. This is the first of 2 videos for today. I did this specifically because I felt like my videos were super long, and somebody, at least one person in your class, had a really hard time downloading the video last time. So I'm going to break them up from now on. Okay. See you on the next video. Y'all take care. Bye-bye.